Hello everyone, today we will look at level 3 of the projectile motion question where you launch an object at an angle but the object lands on a different height. So first off, we have a cannon sitting on a 65 meter high cliff. The cannonball is fired 45 meters per second at 55 degrees above the horizontal. Okay, so let's draw the situation first. Alright, so we have a cliff and then there is an object that's launching at some kind of a speed and it eventually lands on the ground like this with some kind of final velocity at the end, right? Okay, so all the other things are kind of just extra detail. The only thing we need to know right now is the initial launching speed and angle, which is 45 meters per second at 55 degrees above the ground. So we want to use that information to immediately break that into components. So we have 45 meters per second, and we are now going to have two components to worry about. So we have the x component and the y components in here. Okay, so we're going to break x and y component very quickly. So the x component is going to be 42 with a cosine of the angle, which is 55 degrees. So cosine 55 degrees, and then you get your y component. So this will be your vx, right? So this part is your vx, your velocity in the x direction. Now you also have a velocity in the y direction, which will be this v in the y, and that also goes up. So 42 sine of 55 degrees. So they're both positive because one goes right, one goes up. In your calculator, you should be able to get the two initial speed, which is 24.1, and then Vx is 34.4 meter per second. Vy is that. Now, the moment you get this, you have to immediately remember destroy that 42 from your point of view. So that 42 number, that initial velocity is no longer useful. So it has broken into two components. We have your v initial x, which will remain constant throughout the question, and v initial y, which will be something that is subjected to gravity, so it will change, it will decrease. All right, so now, how long will the object be airborne is the first question, which is usually in the y direction world. Remember, we said something about that last day. So usually if you want to get airtime, you have to go into the y direction first. Okay, so the time for this question is going to be something in the y direction. So let's put the y direction numbers down here. Now, a reminder is this is actually same as the 1D question where you just launch an object with some initial velocity upward on the platform and let the object drop to the ground. There's no difference between launching it at an angle and launching it vertically upward and falling to the ground. The only difference is you will not land directly below, you will land somewhere to the right hand side because of your x direction velocity. Everything else is the same. So for example, v initial y is the number that we got earlier on the top. So v initial y is 34.4. So we can use that, 34.4. Acceleration, you are on Earth, so negative 9.8 meters per second. And then your v final y is unknown, and your displacement. Okay, displacement you actually do know. This is a 65 meter clip. So you vertically drop 65 meter. So it's 65 meter, but because you drop vertically by 65, you're starting on the mountain. You're not starting on the ground, right? So you drop 65, so it's negative 65 meter. Okay, now, I thought the question is asking for time, but why do we need velocity first? Because you can't get time unless you're either very lucky, your v initial is 0, or you will need v final to get time. So we actually had to do a v final calculation first, and then we'll move on to get the time. So v final calculation, v final square, v initial square plus 2ad. Everything in here is in the y world, and we have our v final then. So this is kind of your v final y, which is equal to the square root of, so 34.4 square plus 2 times acceleration times displacement. Now, of course, there is a square root on the whole thing, but that is not too difficult. So you will have a final velocity of 49.57 meter per second. Now, this is a vertical final velocity. So it's the speed of the object when it hit the ground in the vertical direction, which is going down, right? Vertically, the object is going down. So again, you can kind of see it from the final stage of the landing of the ball. So when the ball lands on the ground, it kind of goes this way, right? It kind of goes this way when it lands on the ground. So its speed just before hitting the ground has two components. It has a component that is called x, which would be the same from before to after, and it has this component called the y component, which will be, well, the negative 49.57. So it's negative because you are on your way down at the end. Well, with that though, you can get speed. You can get time. So time is just one other thing from here, right? So time, v final equal v initial plus a t. So with that equation, you have enough information to get time, because now your v final is negative 49.57, your v initial is 34.4, your acceleration is negative 9.8. So you add negative 9.8 and then time. So just have to be careful about how you handle like all these like extra negative sign and everything. But at this moment, or at this point in your physics calculation, we have done the 1D version so many times. I hope this is not a challenging thing for you. So you will move the 34.4, subtract, and then divide by negative 9.8. Of course, you get a positive answer at the end, about 8.57 seconds. Okay, so that is your air time. So we have to take a detour. We have to get v final y first, just like the 1D option. And once we are done with that, we can get time. Getting time is also like solving most of the question though. For example, what is the final velocity? Okay, this is actually a funny question because we already got a final velocity. Well, we got part B is what is the final velocity? They want this final velocity, but we actually got the halfway. We got halfway there. We got this final velocity, which is the y direction. But wait a second, we have the x direction though. That's just a number that never changes from the top, which is the 21.4 meter, well, 24.1 meter per second. So we have everything we need to get final velocity. We just have to write it down. Okay, so let's get final velocity down here. Okay, let me cross this off. All right, so B, final velocity. So final velocity, I have the object facing, well, hitting the ground at this moment, and that's my final velocity. And there is a x component, which is going to be the original Vx, 24.1. And then there is the y component that we just got. We got that because we did time. So we had to find that at a certain point, 49.57. Now, you notice again, I'm skipping that negative because I don't want Pythagoras theorem doesn't care about negative. Tangent also doesn't care about negative. So when you're doing Pythagoras theorem and tangent, is generally not important to include those negative in there, unless you're also very careful about where you put your brackets, right? So that was the warning I gave to most people last day. Let me just round it to 0.6 for that one and take a square root. Okay, so length done. Angle. Angle, on the other hand, right, just inverse tangent. Of course it is. So, well, this angle, you have to draw it to see which angle you're getting. For this one, it will be opposite. Now, the opposite is actually the vertical in here, and the horizontal is the adjacent. So, approximately, right? So, at the end, you get your final velocity answer. So, let me write that down in here. So, approximately 55.1 meter per second, and with an angle of 64 degrees below. So it's below horizontal. Okay, so again, there is no reason why we should do north, east, southwest, because we actually are looking at the object sideways, right? So hopefully that was something that came across last day clearly. Final question on this part, which is the part C. So Final part is the maximum height relative to the ground. Now, that's actually a tricky question because a lot of people would do this question and just do half of the answer. So this object goes up and down like this. So technically speaking, maximum height from the ground is this distance right here. So this is called the maximum height. Now, but you won't get that, right? Because your starting position is actually this location. So whatever dx you calculate would actually, well, dy, whatever vertical direction you calculate will actually be starting from your initial throwing position, which is automatically, well, another 65 meters off the ground. So you actually have to do this question, assuming that you're standing on the mountain, throw the object, get the height from your throwing rotation to the object, and then at the 65-meter clip that you're standing on. That will be the total maximum distance. Okay, so what is so special about maximum height? Well, same thing from the 1D location, right? 1D situation. So at the maximum height, you have something special. So some of you in class might be yelling out that answer right now, which is the maximum velocity at the top, right? So when the object is at the top, horizontally it has a velocity, but vertically that velocity is gone. So if you're in the y world, right, in the y direction, then this is what you have. V initial is, well, the same V initial you have, which is 34.4 from the beginning, and V final acceleration is of course negative 9.8, but you have a V final at the maximum 0. So at the maximum, your speed vertically is nothing, which means that is actually good enough if you look at the equation for us to get our displacement. Okay, so this displacement is just the displacement from the maximum, from the launching location to the maximum. Okay, so we have to add 65 to it to actually get the maximum at the end. All right, so since we have no time, so this equation is the best when you have no time. Okay, so V final 0 makes it a lot easier. V initial 34.4 and 2 times the acceleration times the displacement. So I'll let you verify this because this is just something that you have to do in your calculator. So I get about 60 meters, 60.4, right? Rounding it a little bit, which is not the maximum height. That is from your launching location to the maximum height. So from the ground to the maximum height, the real maximum height is that plus the mountain that you're standing on. So total maximum height, 125.4 meter. Okay, so this is the first example for our 2D projectile motion launching on a mountain, landing on the ground. It's not too bad, isn't it? Right? It is not too bad. I mean, compared to level 2 and level 3 doesn't actually have too much of a difference. Okay, well, I mean, you have to try it. You have to try some of the exercise on the worksheet to actually see for yourself. But let's do one more. Let's take time and do one more. So this one. A BMX leaves a ramp traveling at 65 km per hour at a trajectory 40 degrees above the horizontal. He strikes the top of the building, and landing on it 5.8 meters above the ground. Okay, so first when I look at this question, and then they want the horizontal distance from the building and what is the speed when he lands. The first thing I actually notice is the unit of this being wrong. So let's convert that to meter per second. So 18.606 meter per second. Okay, now secondly, I have to draw a picture. I'm actually a little bit confused when I first see this question because in my head, I immediately see two different answers. Now, so what they gave us is the height of the building at 5.8 meters. So we have a building in here, and the building is 5.8 meter, right? So it's from here to here, 5.8 meter. And then we have the car that is going to, launch at an angle. So this is the car launching at an angle, and it's going to go to that building. But here's the thing, though. This car would actually hit 5.8 meter twice, right? It could hit 5.8 meter on its way up, or it could hit 5.8 meter on its way down. And from the current information that they give us, we actually don't know which one is true. Now, I mean, most people would prefer this, which is just like a habit. They think that, when something lands on the top of the building, it should be something like that. You have to go over in order to land on the top. But technically, you could just go just right at it and then land on the top, right? So there are actually two situations. Now, we're going to assume that is this one. And I'm going to tell you later on, what is the only difference in your calculation between the first case or the second case, right? So you could be landing on a 5.8 meter there, or maybe a little bit earlier. We're taking the later time. Okay, so that's pretty much it though. Let's take the initial velocity and break it into component. So your initial velocity is that way, and is at 18.6, 18.06. And then there is a x component and y component. So x component, y component. And the angle is going to be 40 degrees. Okay, so one quick calculator check, you will get Vx and Vy, or V initial x, V initial y. So Vx takes the cosine theta, which is 13.83. Again, you can verify these. Vy is 11.6. That one takes the sine theta, so 18 times sine theta, which is 11.6 meter per second. Now, then from this one on, please don't use the 65. Please don't use the 18. Those numbers are totally not allowed to be touched anymore. Okay, so we only have two initial speed. One is for x, one is for y. Okay, so they want us to find the horizontal distance, which is the range of the building. But wait a moment. If you remember from before, in order to get horizontal distance, okay, so let me just remind you, this question is being very tricky. So horizontal distance can only be obtained after you get airtime, right? So you all remember that. You have to get airtime and then get horizontal velocity distance, because horizontal distance is constant. You need velocity and time for that to find that, which you don't have. But airtime is a y direction thing. In this question, in order to find airtime, you actually have to find the final y first. Which means, even though they're asking you for range, they're asking you to, you're required to do actually two extra calculations. The process to get from v final y to airtime is exactly the same process as what we did in here. So we just assume that we have no v final y, so we have to find a v final y first, and once we find that, we stuff a negative into it, and then we use that to find the time. And once we get the time, we can get the horizontal distance travel. So that one question is actually three questions in one, okay, which is what makes it a little bit annoying to do, or troubling, right? So if you're doing this on your own, you then have to realize that this is what you're doing. So you're actually in the y world right now, okay? So you're in the y world. So in this y world, you have v initial y, which is 11.6. So that's not bad. 11.6. Acceleration negative 9.8. V final y, I don't know. That's what I'm looking for. And displacement. Now displacement is just a mountain. Okay. In this case, your car start on the ground and land on a mountain, right, later on, or on a building later on. So it actually go up, right? I mean, compared your starting location to your final location, you went up. So no more negative for your dy, right? You went up, so positive dy. Yay, for the first time in a long while. Positive 5.8 meter. And that will get you your Vy final. Okay, so let's get our Vy final then. Okay, so the equation to use is Vy final square equal V initial square plus 2AD, because we have no time yet. And we just want to get Vy final. So we put everything else in it. So we put the initial 11.6, acceleration negative 9.8, and time, which is 5.8. All right. Now, and then, of course, we have to take a square root of the answer at the end, right? And this is where the special part actually comes in. When you take a square root, you have to answer plus or minus of that answer. Now, I got the answer to be 4.57 meter per second, but it's plus or minus that 4.57 when you take a square root. It turns out both answers are actually correct. That is the true location that I was talking about, where the building could have been. So if the building was the one that's closer to you, so because right now we actually don't know like which way is, like is it on your way up there or on your way down there that you actually hit the building. So if it's on your way up, this speed will have a vertical part that goes positively. Whereas if you're on your way down, then that speed will have a vertical part that goes down. And that is the positive 4.5 and the negative 4.5. So if we assume it was the first case, then we use positive 4.5. If you assume that is the second case, use negative 4.5. That's the difference. You actually get two completely different answers. Even the time will be different because it takes longer to get to the second building. We are assuming the second case, so we take negative 4.5. Okay? Now, on the test, don't worry. I won't give you a question that is this ambiguous. If it is, I will tell you that there are two possible answers, so give me both. Or I will tell you exactly, are you on your way up or on your way down? Because with the building's height, 5.8 meter being the only other number we have, both situations are possible. And the distance to the building is unknown, right? We don't even know that yet. So that's why like we do have two possible answers in here. And that's okay. So we are going to look at this right now and try to assume that is the negative one, and then use the negative one to, so we pick this one, right? And then we're going to use it to continue and get time. Okay, so get a time. So time V final equals to V initial plus AT. So time is still in the Y world. So we are still in the Y direction. So we can use these numbers that we just got. So negative 4.57 initial 11.6 plus acceleration. And our airtime is just there. So airtime is done. 1.65 seconds. Okay, so we have a V final. We now also have like an airtime. Now we can get range. Oh God, right? So the original question was going after range, which is your horizontal distance. And at this moment, let me cut this page like that because I can use the other side. So we are still on part A. Okay, so finally we can get the range. Okay, but X direction range should be easy. Because in the X direction, there's only one thing you can do. Velocity equal distance over time. So distance equal to velocity times time. Horizontal velocity is 13.83. You have to look at the initial breaking into component portion to see that number, and then the new time. And that's it. About 22.8 meter. That is the final answer to the distance to the building. So the distance to the building, if we assume, again, right, if I'm being more thorough, I should actually give you two answers. But this is the distance to the building, assuming you're on your way down when you land on the top, right, on the roof. So if you assume that you're on your way up, you'll get a different time, and then you'll get a different distance, which will be to the first building, not to the second one. Okay, so we are assuming that we are on the second one right now. Okay, so with that, what is the final speed? That is actually the easy part. You find that you always, because on your way calculating time, you already got the V final Y, which is like this number in here. Getting the final speed in every question is basically just an afterthought, right? It's like, oh, I did 70% of the work already. I just need to put it together. Because you have to get that in order to get time. And you usually have to get time in order to get anything else. So by the time they ask you for your final velocity, you have already done most of the work. So now just put it together. Okay, so part B, final velocity, which is a standard issue thing. So final velocity. So the object lands on the building, which goes this way. It has two components, x and y component. The y part is from our calculation, 4.57. So we had to get that for our time. The x part is the same x, which is from the beginning, 13.83. Oops, 13.83. Okay, so there. Then we use our best friend in vector addition, best friend couples, right? Pythagoras theorem and tangent, of course, right? So you can try that. I think I'm just going to write down the final answer for this one. So Pythagoras theorem, after you're done, should be 14.6, and angle 18.3 degree below horizontal. Okay, so that is it for our final question, which is also the end of our 2D kinematics unit. All right, see you in the next class.